He started in 2011 in class 45. Bob is a retired math teacher and a sailboat racer. And I want you to know he's giving these two presentations today, but he agreed to give his currents and weather in the end of January 21st and 27th, if anybody wants a refresher. So with that, here's Bob.
Okay, welcome.
Oh, wait, I have one more thing to say. Bob, now, everybody's got to tell me who gets this or not. Bob never met an imaginary number he did not like.
Okay.
You're supposed to laugh. I only see one person laughing. Oh, well. Onward.
Okay, I'd like to thank Norm and Denise Thorne for all the work they've done on these presentations. I don't want to duplicate anything Paul Funk did because that was a masterpiece. So since the lighthouse is such a big part of our museum now, I thought I'd give you a little bit of what a sailor would look like, because the lighthouses were designed for sailors. And so I want to fill in a little bit, give you a little bit of background. I'm going to start with the Point FERMIN lighthouse because it's a little simpler. It's actually a lighthouse. It's an old-fashioned one. This comes from 1854. This is what it looks like offshore if you're in a boat. Actually, it's from a helicopter. And you can see it, there is a definite point here. But when the sailor looks at a lighthouse, he looks at the chart. So this is what a nautical chart would look like of Point FERMIN. And if you can follow my pointer here, I'm going along the shoreline. So everything above the pointer is land, and everything below it is ocean. And you can see this little magenta flash here. Whenever you see a magenta flash, here's another one. This is a light. And the little dot there is where the lighthouse is. So if you know exactly where it is on the land. And it tells you right here that it's Point FERMIN. But what you're interested in is what Paul Funk calls the signature of the lighthouse. And this is a signature down here. I put it up on top, up along the top here, so you can see it a little bit better. But if you're looking on a nautical chart, the signature will be right next to the lighthouse, and this is where it is. So let's see if you can be a little bit of a navigator and figure out what this is trying to tell us. Just to make a guess as to what you think FL would mean.
Flash.
Flashing. How about 10S?
10 seconds.
10 seconds. So if you're at night, you will see a flash. And then 10 seconds later, you'll see another flash. 10 seconds later, you'll see another flash. If there's no color here, it's flashing white. Now we have 120 FT. You want to guess what that is?
120 feet above sea level?
Exactly.
The distance.
Sea level. I'm going to come back to that in a minute. And then there's 13M.
13 meters for what?
13 nautical miles that the light is visible.
Wow. He was one of my students. I'm really proud.
Oh, okay.
13 nautical miles visible. Now that's wishful thinking if you're in a sailboat. If you're in a cruise ship or a container ship, yeah, but we're down close. The curvature of the earth pushes things around. So 6 miles, but that's plenty. You've got 6 miles to avoid the land. But this is where the signature would be. There's another light down here, and it's a little different shape. And the name of this is PF, 6PF. Anybody want to guess what PF stands for? About Point FERMIN.
Yeah.
Wow.
Sorry. So this is the Point FERMIN bell buoy. The R means it's red, and they have numbers. So this is bell buoy or buoy number 6. If you had R10, remember the R10 buoy where we're looking for the whales? So that's a red buoy number 10. That's the name, like Point FERMIN, a lighthouse, Point FERMIN buoy. This is the signature. FL, you already know what that is. That's flashing. How about R? What do you think R is?
Red.
Red.
F4S?
Seconds.
4 seconds. So this is a flashing red every 4 seconds. Then it says WHIS. Now that sounds for whistle. So there's 3 types of noise that buoys make. The whistle buoy is like a big organ pipe inside the buoy, and as it goes up and down, the pressure from the wave sets it off and it goes womp, 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 as opposed to a bell buoy, which goes ding, 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 and opposed to a foghorn, which would go beep, beep, beep. So they're very easy to tell apart. So if it's in the fog and you hear womp, 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 you know you're off of Point FERMIN and not maybe R10, for example, which is a bell buoy. We can move on here. This symbol here, this is kelp. But more important, you'll notice the ocean part here is kind of light blue, and there's a line right here, going right along here. Right? Can you all see the pointer okay?
Yes.
Yep.
Great, okay. And then you see a 9 over here, and you see an 8 and a 10. So those are fathoms. Now this is, a fathom is 6 feet. That's how much line you would pull in if you stretched your arms all the way out. So if you're pulling up the anchor, you'd pull up 1 fathom of line at a time. So depths are always measured in fathoms. So this is 10 fathoms or 60 feet. Right on the other side of this line is an 11. So this is 11 fathoms. So this line right here is called the 10 fathom line. You notice it's blue inside. So this is the area you want to avoid. But for us, there's something more important. This other line here is not real obvious, but will be in the next one we do. This is the 20 fathom line. And for us whale watchers, the whales tend to stay within this zone. If Henry's here, he can tell us about this, but the whales tend to be between the 10 fathom line and the 20 fathom line. That's where you'd normally see the gray whales.
So Bob, on
Yes.
those fathoms, with different tides, would those fathoms vary?
Yes, this is measured at low tide, mean low or
Okay.
low water. So you have at least 10 fathoms and more if it's high tide. Yeah, good question. When it's very shallow, see where it says 6 and 5? So excuse me, that's 6 fathoms 5 feet, 7 fathoms 2 feet. Notice by the Point FERMIN buoy, it's got 0 fathoms 2 feet. So there's only 2 feet of water there at low tide. You do not want to be in here, which is why there's a buoy there to mark it out. One other little thing here, this is a rec. That's what a rec says, position approximate. And up on top, we don't have the light, but this is the signature for the Angels Gate light, the entrance to Los Angeles Harbor. And it's a flashing, the G stands for, now you figured this out probably,
Green,
15S,
15 seconds.
73 feet. And it's visible in theory 14 miles. And then it says horn. So if you hear the beep, beep, your typical foghorn sound, you know that you're off the Angels Gate entrance to Los Angeles Harbor, as opposed to the womp womp, which you normally won't hear. Only boaters really hear the womp womp kind of thing because they're usually further out to sea. Okay. Let me go back 1 second here. Oh boy. This is remember we wanted to know how high the lighthouse is. I know where I wanted to go. You all remember from your high school trigonometry that the opposite side over the adjacent side is equal to the tangent of the angle. Bottom line is, if you know how high something is and you know the angle to it, you can figure out how far off you are. Okay, now that's all you need to know. And how do you measure the angle? Well, Columbus had one of these. This is called an ASTROLABE. And they're very accurate, but hard to use at sea. I made a very nice copy of one that I was going to put in the museum. And this will measure the angle from a lighthouse to the water, or a star to the water, or the sun to the water. They also used cross staffs. And to use a cross staff, you line the bottom part of this cross with a star or the sun, and you move this back and forth, and then the angles are measured on there. This was a very popular instrument used. It's very difficult to use. Columbus had one of these too, and that's what they normally used at sea. Now, do you think that all of us sailboat people go up and down the coast doing trigonometry problems? No. What we do is we have a table of offsets. So I made a one here, and this is just took me 10 minutes. So here's Point Vicente. So if you get a 5-degree angle on a sextant, which is what we use now, you're 2,000 feet off. 10-degree angle, you're 1,000 feet off. Everybody following me here? If you have a 30-degree angle, you're too close. That's dangerous. Here's Redondo Beach, 5 degrees off would be 1,880 feet, 2,000 feet. If you have 45 degrees here, you're eating at Blue Water Grill because the Redondo light is way inland. So you have to be more careful when you're off of Redondo, although there's really no big dangers like there are at Point Vicente. But most of the sailors, BC now, before calculator and computer, had to have one of these tables here that we would read off, and that would keep us safely off the rocks. This is another chart. This is what the big ships use. A little more difficult to read, but they're like 4 feet by 4 feet. So we use that chart that I had up above. Okay, now we're ready to take on Point Vicente, which is a little more difficult. You've all seen this picture. This is what it would look like if you're on a helicopter. And you can see that Point Vicente is a point, definitely. And here's a foghorn I mentioned. And our museum is back here, just to orient it. So there we go. And this is the chart that you would see at Point Vicente. You notice there's a little dot there with the magenta. So the lighthouse is right there. You know exactly where it is. Clearly marked Point Vicente. And here's the signature. You should notice a contradiction here. I made it bigger up on the top. It's a little more complicated. Flashing every 20 seconds. What do you suppose that 2 stands for?
220 seconds.
2 flashes per cycle. So in theory, it would go flash, flash, and 20 seconds later, flash, flash, 20 seconds later.
Oh.
This is true. I've sailed a lot in British Columbia and Canada. I've done a lot in Mexico, the Mediterranean, the Caribbean. And when you see an FL2, it goes flash, flash, and then you count out the number of seconds, flash, flash. In Mexico and the Coronado Islands, there's a flashing 3. So you would see flash, 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 and then 15 seconds later, flash, flash, flash. Point Vicente doesn't quite work that way. It's an oddball, and hopefully Paul Funk's here, and we can get him in on the discussion later on. It's 185 feet above sea level, and so you can do your table of offsets, tell how far away you are. It's visible for 24 miles in a big ship, and it's got a horn. Now, horn is the one foghorn that you're all familiar with, the beep, beep, beep kind of sound. There is a contradiction here. This says
It's
20.
not working at the moment, is it?
Pardon?
Paul, the foghorn doesn't work at the moment, does it?
Yeah. Yeah, if there's fog, they wouldn't put it on, and unless there's fog.
That little hut's gone though, hasn't it?
Yeah, I can hear the Redondo one very clearly from my house, and the sea lions barking. This says 14 miles down here in the signature, if you can read it. So this
Right.
this comes off of a chart book, they call it, for small craft. And so in a sailboat like mine, you can see it 14 miles, and on a cruise ship, this is the official signature. And if you ask me what the signature is, this would be 24 miles. These
Going
little,
back to the sound of the foghorn again, I haven't heard it for years.
well, I don't live there, so I don't know. Maybe somebody.
I don't think it's going
It
anymore.
was removed.
Say it again.
It was removed when they shot a movie there. Or before that. It's been gone for quite a while.
Oh, that's interesting. Josh, I didn't know that. You learn something. Every time I go to the museum, I learn something.
While you've got this chart up, I believe that this chart reflects the old light, not the new one. The new one doesn't have anywhere near, as I'm told, a range above. I was told the new range for the new light is 14 miles max.
Is Paul Funk here by any chance? He's our local expert.
Right.
I don't know.
Anyway, I think these are numbers for the old light.
Well, this is an old chart, yes.
Well, yeah, so the foghorn is gone and the throw distance of the new light is less.
But these little asterisks, these are the rocks. This one right here, this is whale rock. You can see a reef coming out here. There's a 0 feet. It's above water. This shows the 10 fathom line a little bit better. There's a 12 on one side and 8 on the other side. So this line is, this is where the 10 is. So 13 here, 7 here, and it comes around. And you can see that the whales pretty much follow this line. And here's the 20 fathom line, very clear. There's 26 on this side, 17, 33, 13. So this is the 20 fathom line. And this is the zone pretty much where the whales would go along here. If you've been watching them, you'll see that's pretty much true. Some of them are more offshore, but most of them follow this little narrow zone.
You're talking about the gray whales, right, Bob?
Yes, only the gray whales, yeah.
Yeah.
The fins stay way offshore, generally speaking. This is the chart here from a larger ship, and you can see it does have the 24 miles, and it's got the horn on it there. The Redondo Beach Lighthouse is on the old Edison plant. There used to be 2 smokestacks here. They took them down, and they were in the process of taking the others down when the energy department made them stop. The light is right here on this little corner.
Wow.
Okay. Wow. And it's way inland. This is what Redondo Beach would look like if from a helicopter, again, not a ship. And the light is right over here. The Edison plant, that's where the light is. This is a little bit of a picture. It's not quite easy to see. The signature is there, but I put it up on top. So this is flashing 5 seconds. It's 165 feet above. And then it's a privately maintained light. It's the Edison company maintains it. And so they don't put a lot of details so they don't get sued. Literally true. But you have enough information here to do most of the stuff that you need.
Bob.
Yes.
Bob.
Yeah, I'm here.
Isn't the Edison plant coming, isn't it going to be torn down eventually?
It depends on whether you read it on an odd day or an even day in the newspaper.
Well, what I'm saying is, what would happen to the lighthouse? What do you think would happen to the lighthouse?
That's a good question, because that's a powerful light out there. That's a really good light. Oh, it would cost a lot of money to put a real light there.
Yeah.
I don't know. Marina Del Rey does not have a big light, by the way.
Hey, Bob.
Hmm?
Bob, can you hear me?
Yes, I can.
Hey, this is Diane. I have a kind of a stupid question because I don't know. It seems that most of the lights, like off of Point Fermin and Point Vicente, are right on the edge of the bluff. Why does we have a light King Harbor, the Edison, when you still have kind of jetty out? So wouldn't that make the boats get too close to little inlet there? Because it's not at a bluff.
Yeah, that's why you've got to read the chart pretty carefully, because you're coming in here and the light's way over here.
But if you're out that little inlet, then you're in trouble, right?
Right. None of this existed before. This is all man-made.
Oh.
So the shoreline's along here. But so this was built in the 1960s by the Corps of Engineers. So this breakwater is totally artificial. So none of this was there when it started. This is a little picture of King Harbor, but this is the entrance. Let me go back. This is where
Bob,
yes.
Bob, may I have one correction. The breakwater of the harbor was constructed in the 1930s as a WPA project. The yacht club on the mole was constructed in 1960. So
thanks, Bob.
But the harbor goes way back pre-World War II.
Oh, wow.
And Bob,
Yeah.
I have a question about the lighthouse, or about the light in Redondo Beach. Is that controlled by the Coast Guard?
Controlled by Edison. They're totally responsible for it.
I'm sorry?
Edison's totally responsible for it. It's a privately maintained light. They could take it down tomorrow. But they've been
Okay.
very nice.
Thank you.
When you're coming into a harbor, there's a rule called red right returning. So as you're entering here, you'll notice that this buoy is red. And this light right here, its signature is flashing red. So you want to keep the red buoys and the red lights on the right-hand side and the green ones on the left-hand side. I think you can see that if this light was on your right-hand side, you'd be on the rocks. So I'm sorry, if this was on the left, you'd be on the rocks. So the rule is you keep the red lights always on your right when you're returning to a harbor. So the buoys on the right-hand side will always be red, and any kind of marker will always be green on this side. So this is the end of the breakwater, and this is its signature right here. It's flashing, it's green, 4 seconds, 35 feet, visible 4 miles, and it's an odd number. All the ones on the left side will be odd numbers. So this is number 3. This down here is number 1. There's a little buoy right here, this little flashing one here. So this is number 1 and it's green. There's no other information because it's intermittent. This is the Redondo Beach bell buoy. And can you guess what the RB on it means?
Redondo Beach.
Redondo Beach, and it's called RW. So this is a red and white buoy. And if you're next to it, you'll see an RB on the side. And it's a bell buoy. There's no other information. The light doesn't have any sequence. It's very, very dim. It's actually a hazard to navigation. When you're coming in, there's so many lights on the pier here that you can't even see the darn thing. The only way you can see it is because it's a shadow going between all the other lights. And so at night, it's actually, I think it's more of a hazard than a help. During the day, it's pretty good.
Hey,
And
Bob.
yeah,
Oh, sorry. I didn't interrupt. Go ahead, finish.
that's it.
Oh, so when the boats are going in, like you said, on the right side, it's red, so you're going in, correct? And then left as you're going is red, is green, right? Sort of
Yes.
like when you drive a car, you're in the right-hand lane or the left-hand lane.
Exactly, yeah. Yeah, they're
So
actually,
what happens,
go ahead, I'm
so what
sorry.
happens if you're in England, is it the opposite? It's a joke, I'm sorry.
I believe this is an international thing.
Okay.
But I've never been to England. We drove, my sister and I cruised to Caribbean and we rented a car. She got stuck driving. And it had to be, she was driving on the left side. And boy, that was.
I know the answer to that.
Yeah, go ahead. Go ahead.
I have the answer to that. Yeah, European uses the international standard. European places use the international standard turning. In Tahiti, and some lagoons seen on the reef side and red on the volcano side. No, I don't hear me.
Who's talking?
It's very difficult to hear a person other than Bob talking. They're breaking up.
And
Right.
Okay, so the ones on the right hand, this is a buoy, and this is a red. The N stands for nun, so they look like a nun's hat. So they're called nun buoys, and they're even. So if you see an even number, you know that's on the right-hand side of the channel. This light here, this is on the end of the other jetty, and you want this to be on your right-hand side when you're coming in. And we've already went over this one, and it's got a horn on it. So that's about all I have on the lights. It's just a short little thing to give you a little bit of something depth when you're standing in front of that the the light that we have there, and you run out of things to think about. The main thing to remember is that every one of them has a signature. And each one is unique, and it's designed so that you won't confuse one for the other one. In this case, they're both 4 seconds, but one's green and one's red, which doesn't do me any good because I'm colorblind, but the normal person wouldn't have a problem with it. This one will look like a nun. This one is a can. That's what the C is here for. Looks like a beer can. And this is even numbers, and these are odd numbers. And so using that, you've pretty much got things. Rivers are totally different. There's a totally different river system, and I'm not familiar with it, but it's very different than the ocean system, called inland waterways. So that's all I've got for you. If you have any more questions, open it up. Anything that I can help you with, I'd be glad to.
And Crane something just popped up from him, but it stayed for a couple of seconds.
Yeah, I missed it. I couldn't get it. It was breaking up.
It's in the chat box. It says Europe uses green right returning the international standard.
Great, thank you.
That doesn't make any sense to me, but I'm not going to argue. I know in Canada it's red, in Mexico it's red, Caribbean red. And when I was in the Mediterranean, I don't remember. Interesting. I got to look that up. Wouldn't it be nice if we could all agree and do everything the same? You know,
Yeah, really.
In your dreams.
Can I say something to Elena? Elena, don't forget to talk about next Friday, our lunch.
Okay. And I heard you. I got it.
This is
Okay.
Cindy at the Point Vicente Interpretive Center. I'm so positive I've heard the foghorn. So I'm going to pay special attention to that next time I'm working when it's foggy, because I know when I've worked weddings late at night, I have heard it. I've been there 12 years, so I can't say if it's changed within the last 12 years. That's possible, but I know I've heard that foghorn. So now I'm going to definitely go to work on a foggy day. And
I have one more comment that's very related to what we learned here. This dotted line here and this dotted line here, this is called a sector. And so this light is only visible when you're in this sector. So if you're, for instance, if you're sailing along and all of a sudden you're up here and you don't see the light, you know you're too close. And that's called the sector of the light. And so that helps a lot of navigation. I firmly believe that they should go further down this way.
I'm sure the foghorn is gone.
But anyway, this is where the thing about the ghost in the lighthouse came. In order to get the sector, all they did was paint the back of the lighthouse with white. And that would black it out in any other part of when it's rotating. Well, they didn't put enough paint on. They were a little too cheap. And so as the light would go around, it would see the shadow going around every 20 seconds. A shadow would come around that white. And that's where the myth of the lady that was the ghost in the lighthouse came from. They got more paint and they covered that up, and now we don't have a ghost anymore.
Oh, shucks.